Yeah, good morning all. Now I am going to explain about signal flow graph. Now see here, it is a signal flow graph. This is a representation of signal flow graph, right? From this signal flow graph, we need to find out the transfer function. Okay, now see here, to find out the transfer function, we need to use Mason's gain formula. Okay, Mason's gain formula M is equals to output by input, that is C of S by R of S is equals to summation k is equals to 1 to n mk m suffix k delta suffix k by delta. Okay, where mk is the kth forward path. Okay, delta k is the value of delta which is non-touching to the mk forward path. Okay, while solving the problem you will understand everything. Okay, here in this problem delta is 1 minus sum of loop gains plus sum of two non-touching loop gain products minus 3 non-touching loop gain products, that is delta. Okay, see here C of S is the output node, it has only incoming branch. Now see here, this is a C of S, right? Okay, this C of S is a output node which is having only incoming branch. Okay, this is the representation, it is having only incoming branch. Okay, this is incoming branch, right? Where R of S is the reference input, this is having only outgoing branch. See here, this is R of S, this is having only outgoing branch, this arrow is outwards, right? Whereas C of S is output which is having only incoming branch. Okay, now from this signal flow graph we need to derive the transfer function. Okay, first of all we need to know about forward path. Okay, forward path is nothing but it is a path from source to destination. Okay, or that means R of S to C of S. That means in this path there is no repetition of node occurs. Okay, now see here, from this forward path it is having how many nodes? 1 2 3 4, right? It is having 4 nodes, right? 2 3 4. Okay, first forward path, see here, from R of S to node 1 to node 2 to node 3 to node 4 to C of S. This is one path, there is no repetition of node occurs, right? That means forward path 1 is having 1 2 3 4. Okay, that is about forward path. If we consider forward path gain is equals to product. Okay, here it is having G1, G2, G3, right? Then forward path gain is G1, G2, G3. Okay, that is one forward path. Next, another forward path is, okay, from R of S to 1. Okay, this is another path. Okay, forward path is having straight line current direction. Okay, not opposite. Suppose if you consider this one, again this node is repeated once again, right? That means again forward path is only one direction, that is from R of S to node 1 to node 4 to C of S, right? That means 1 to 4 only. Okay, if we consider forward path gain 2, that is it is having only G4. Okay, that means for this signal flow graph it is having how many forward paths? One forward path. Okay, this is again another forward path, it is having 2 forward paths. Okay, next, loop. Okay, loop in a signal flow graph is the path starting from the originating node to again back to the originating node. That means see here, this is one loop, G12 minus 1, right? That means this loop is starts from one node ending at again same node. This is nothing but a loop, right? That means this signal flow graph is having loop 1, loop 2, right? That means loop 1 is equals to loop gains. Loop gain is G into minus 1 minus G. Loop 2 gain is G2 into minus 1 is nothing but minus G2. Okay, what is my delta? Delta is equals to 1 minus sum of loop gains. Okay, sum of loop gains, how many loops are there? L1, L2. Okay, L1 value is minus G1, L2 value is minus G2, right? That means what is the formula? Delta is equals to 1 minus sum of loop gains. That means 1 minus L1 plus L2. Okay, 1 minus L1 plus L2. Next, sum of two non-touching loop gain products. That means these two are the two non-touching loops, right? That means product of these two loops. If I write the formula delta value, if I write delta value here, 1 minus, here loop 1 value is minus G1, loop 2 value is minus G2, right? Then delta value is 1 minus L1 plus L2, that is sum of loop gains. This L1 is first loop gain, L2 is second loop gain, sum of loop gains. Next, plus sum of two non-touching loops, right? Here there are two non-touching loops are there, L1, L2. There is no relation touching, there is no contact from L1 to L2. That means plus L1 into L2, right? If I simplify this equation, I will get delta value as 1 minus L1 value is minus G1, minus of minus plus G1, plus minus into plus minus, minus of minus you will get again plus G2, plus L1 L2, product of L1 L2 will be minus into minus plus again G1 G2. Okay, this is the value of delta. Here there are no three non-touching loops, right? Then you can leave as it is. This is the value of delta. After that, what is the formula? Moissan's gain formula M is equals to K is equals to 1 to N Mk delta K by delta. K is equals to 1 to N. N value is nothing but number of forward paths. Already we seen here, right? How many forward paths are there? Forward path gains are 2, right? This is forward path. These are the forward path gains. That means how many forward paths it is having? 2 forward paths, right? That means from this formula Mk delta K, right? K equals to 1 to 2, right? That means M1 delta 1 plus M2 delta 2 by delta. Already delta value is calculated, right? Okay, M1 is nothing but first forward path 1 gain 1, right? G1, G2, G3. Okay, next see here, delta 1 is nothing but the value of delta which is not having the value of delta which is not touching kth forward path. Now see here, what is the delta value? 1 minus L1 plus L2 plus L1 into L2, right? Okay, that means this is kth for first forward path, right? Okay, in this first forward path all loops are touching, right? Note, right, this for this forward path loop 1 is touching, loop 2 is touching. That means every loop is touching. That means this value will be 1 minus all. If loop is touching, this value is 0, this value is 0, this value is also 0. That means 1 minus 0 plus next M2 value is nothing but second forward path. Second forward path gain will be G4. Okay, G4 into, now see here, for this forward path also loop 1 is touching, loop 2 is also touching, right? Again it value is again 1 minus 0 divided by delta. Delta value will be 1 plus G1 plus G2 plus G1 G2. Okay, this is nothing but this is the transfer function of a given signal flow graph. Okay, in this way we can find out the transfer function. Okay, now see here, this is another problem. Here also we need to calculate C by R from this signal flow graph, right? First of all, we need to identify number of forward paths. Okay, what is the formula? Moissan's gain formula, right? First forward path, this is one forward path. Okay, that means for this first problem, forward path 1 is equals, forward path gain 1 is equals to G1 into G2 into G3 into G4. G1, G2, G3, G4. Next, forward path gain 2. Okay, this is another forward path, right? Okay, that means forward path gain 2 is equals to 1 into G5, that is nothing but only G5, right? That means M1, forward path gain 1 is nothing but M1, forward path gain 2 is nothing but M2, right? only two forward paths are present, right? Then C by R is equals to, what is the formula? M1 delta 1 plus M2 delta 2 by delta. M1 value is calculated, M2 value is calculated, right? Next, delta is equals to, what is the formula? Okay, first we need to find out loops. Okay, this is one loop, right? Okay, loop 1 is equals to minus G3 into H2. Loop 2 is equals to minus G4 into H3, right? Loop 3 is equals to only H2, right? Minus H2. Okay, from this diagram. Okay, now coming to two non-touching loops. That means 1, 2 is non-touching, 1 and 3 and are non-touching, right? Then L1, L2 are two touching loops. Okay, L1 and L3, L2 and L3 are two non-touching loops, right? That means L1, L3 value will be, see here, this is H1. Just observe here H1. Okay, L1, L2 value is, L1, L3 value is minus G3, H1, H2. L2, L3 value will be minus of minus plus, right? Here also plus G4, H1, H3. Okay, then the value of delta is equals to 1 minus, okay, delta is equals to 1 minus L1 plus L2 plus L3, right? Minus of minus you will get plus. Loop 1 value will be G3 into H2. Loop 2 value will be G4 into H3 plus H2. Okay, after that plus product of two non-touching loops, right? That is G3 into H1 into H2 plus G4 into H1 H3. Okay, this is delta, right? Delta 1 value, see here, what is the first forward path? G1, G2, G3, G4. Okay, this forward path is having all loops. That means delta 1 value is 1 plus it is touching, that means all these values will be 0. Okay, next delta 2 value is equals to, delta 2 value is nothing but the forward path 2 which is not touching loops. What are the non-touching loops? Loop 3 is non-touching. That means loop 3 H1 is not touching, G3 H2 is also not touching, right? Then we need to consider all those values from this equation. 1 plus G3 H2 is not touching means non-touching loops are present. 1 plus G3 H2, here G4 H3 is present means this value is 0. H2 is present. Again sum of two non-touching loops, this is also present, right? That is G3 H1 H2. Right, delta 2, the value of delta which is non-touching loop to the second forward path. Second forward path touch one loops, what are those? G3 H2, right? Next only H2 and G3 H1 H2. Okay, if you substitute delta 1 delta 2 M1 here, you will get directly transfer function. Okay, C by R value you will get. Okay, next similarly you can solve this problem also. Now see here, this is having one forward path, right? G1, G2, G3 same direction, input to output only one path. Next, that is G1, G2, G4 is one forward path. Next, G1 to G2 to G4 is another forward path, two forward paths. Next, see here G1 to this point to again G4 to C of S, total three forward paths, right? Next, one closed loop, that is L1 G4 into H1. Next, G1 G4 into minus 1. Okay, that means minus g1, g3, g4 into 1, 2 loops. Okay, in this from this problem you can easily calculate transfer function. Okay, thank you all.